Hi, I'm Jaden, and for my learning objective, I chose to dive deeper into Choropleth maps, and today I'll specifically talk about Bi-Variate Choropleth maps. Um, and in the week 3 lecture, we briefly went over Choropleth maps, um, which are just thematic maps that allow you to present statistical characteristics within certain boundaries. So, for example, here in these maps, um, I have the counties of Massachusetts separated out, um, and this map here shows um, just shows the percent of the population living under the poverty level for each of these municipalities or counties. Excuse me. Um, and this just allows us to uh, compare these counties to each other. And this data is normalized as it's a percentage already. It's already a proportion, so it doesn't favor um, populations or counties with higher populations, um, which is good for comparison between the two. So it doesn't skew our understanding at all. Um, and then for bivariate choropleth maps, you're going to need at least two, or you need two of these univariate maps. This is called a univariate choropleth. And for a bivariate, you need two, obviously given bi meaning two. And here we have a map of the percentage of conserved area in each of these counties. In most of your data, like this data here is taken from the census, the 2021 5-year census, 5-year estimate. And this I had to derive from this data. This is actually all of the conservation areas in Massachusetts. And to do so, you would just select by attribute. So you'd select by everything within, I'll go to a county I know. By everything in Barnstable County, for example, it'll pick every single one of these individual locations and put them in a table for you, which just allows you to calculate the data you need from that. So I use that to calculate the total area of conserved land, and then you normalize that by the total area of acres in each of the counties. Again, this makes it so we don't favor counties with larger areas, like Worcester County, for example, compared to Dukes County. If you're just comparing by the acres of conserved land, Worcester County would be incredibly larger. You can see that right here. Take that away. Yeah, Worcester County becomes one of the most conserved areas because it has the most actual conserved area. But when you're talking about that proportion, it doesn't matter what has the most. It's about the actual proportion, which is important when you want to understand how these characteristics actually affect areas. Which brings us to the bivariate map, which allows you to overlay these two variables on top of each other, which will show you correlation between the two variables pretty well if your data is actually allowing for that. Here you can see super clearly, like this Suffolk and Bristol, super high poverty, really low conserved area. Barnstable, Nantucket, super high conserved area, super low poverty. That's a super obvious correlation there, and these other ones show that to less dramatic degrees. And this allows you to create arguments for assignments and stuff like that. This is a final project I'm working on for another class. But this technique is super useful to just be able to compare these two maps by overlaying them one on one. It really blends the two statistical categories, and that gives you this little square legend here, which shows you like the dark purple is high poverty and low conservation. This blue is, or this like kind of like ocean blue is high conservation, low poverty. So you get those ideas really quickly, and like you see, there are no areas that fall into this high conservation, high poverty. It doesn't exist. There's none like it. We do have the low conservation, low poverty on this like 495 belt here, but that's largely because there's a bunch of new development, which is all by people with money. Yeah, if you're building a home, you're gonna have money. So it's a given. And then for these, you can choose a larger grid. If you'd like two, you can go between 2 and 4. I think 3 right here is the sweet spot. 4 gets a little hard to read because now you have 16 different groups, which is difficult to interpret. And then a 2 by 2, I just don't think is enough to really show your stuff. I think for this it wouldn't be too bad, but I still prefer the 3 by 3. But that's obviously just my opinion. I think it helps with readability, at the very least. But the ability to do this statistical analysis visually is really beneficial, because you could take the time and do all the actual statistics on this and get your R value and your R squared and check the correlation and get the percentage and make your statistical statement. But this is so much more presentable and so much more useful in an actual application of doing this kind of spatial analysis. So I hope this was helpful. I hope you learned something from this. And thank you for watching.